Okay guys, this is a video explaining potential energy and kinetic energy conversions. It's going to explain how potential energy transforms or converts into kinetic energy and vice versa. So this simulation shows a skateboarder on a skateboard ramp, and when I hit the play button, we're going to see how he's going to go down the ramp and then back up the ramp. At the same time is a handy bar graph here, and it's going to show you how kinetic energy and potential energy change as he starts to move. He is starting off at the highest point, and we know that gravitational potential energy depends on his mass and it depends on his height. Since he's at the highest point, we call this GPE max. It's gravitational potential energy maximum. It's at the highest point. And since he has not started to move, kinetic energy equals 0. So total energy equals GPE max at this point, right? The total energy is made up completely of potential energy, okay? And you will also see as he starts to move, potential and kinetic energy are going to change, but the total energy does not change. The total energy is always constant, and we're going to learn that coming up when we talk about the law of conservation of energy. Energy cannot be created or destroyed. It's constant, and it's going to stay right there at that amount. All right, let's start moving him. And okay, you should have observed that as he started to come down, he's decreasing in his potential energy. Why? Because he's getting closer and closer to the ground, so he's losing height. And if he's losing height, he's losing potential energy. He does not have as much potential energy here as he had here. So where's the potential energy going? Well, it's turning into kinetic energy, right? The potential energy converts or transforms into motion, into kinetic energy. And I'm just about at this halfway point. So they're just about equal at the halfway point. KE equals PE, okay? And if you add KE plus PE, it would equal the total energy, which once again does not change, okay? So at this halfway point here, PE is decreasing, KE is increasing, and they're about equal. Okay, continuing along, right at the bottom, potential energy is 0. Why is potential energy 0? Because he does not have any height, and potential energy depends on mass times height, and height is 0. So potential energy is 0 at the very bottom, but kinetic energy is maximum. So at the very bottom, all of the energy has been transformed into kinetic energy. Total energy hasn't changed, but it is equal to KE max. So KE max is at the bottom, the lowest point, where PE equals 0, KE equals maximum, okay? And we're going to keep on going. He's up, he's climbing up the ramp, so potential energy is now increasing. It's increasing because he's going higher and higher and higher and higher, up to at some point, once he's up here, it's going to be PE max again. And as he's increasing in height, his kinetic energy is decreasing. So he's kind of slowing down, right? He's losing speed as he's going up and up. But right about at this halfway point, PE equals KE. And once again, total energy always equals KE plus PE. And that's not going to change. All right, we're going to go back up to the top again. Bam, there he is. He's at the top. And once again, we're at the highest point. So at the highest point, we have PE max and KE 0, okay? All right, so that should be clear. You should understand the term PE max. That's right there. You should understand the term KE max. That's going to be at the bottom. Let's just double check that. Bam, right there, okay? So KE max is at the very bottom. You should know PE equals 0 when KE equals max, and KE equals 0 when PE is max. And you should know total energy never changes, and you should know that total energy equals kinetic energy plus potential energy. Okay, let's play around briefly. Let me get him back up to the top. There he is. And let's, oops, I wasn't quick enough. Let's go ahead and you can just continue to watch how PE and KE change. All right, we'll leave them right there. Okay, let's show the speed, the speedometer. So what we want to show is that kinetic energy is dependent on speed. So as he is headed toward KE max, his speed should be increasing, right? As he's getting closer and closer to the maximum kinetic energy, which we already said is down here, his speed should increase. And as he leaves KE max, as he gets higher and higher and higher, as potential energy increases, his speed should decrease, okay? So kinetic energy depends on speed. The more speed there is, the more kinetic energy there is. So let's see if this is indeed true. Okay, he starts to go, yep, speeding up. Maximum speed, slowing down, slowest speed, speeding up, maximum speed, slowing down. Okay, so I was not quick enough again. I think I have to play it all the way through. If I try to stop it, mess it up. All right there. Okay, so you should also now recognize that kinetic energy depends on speed, and that as kinetic energy is increasing, speed is increasing. If kinetic energy is decreasing, speed is decreasing. All right, let's now look if we add mass. So now let's make a bigger skateboarder. Let's make him a really big guy. Okay, so he's huge now, right? So we started off here. He was a small guy, and now he's a big guy. So the total energy of the system now starts out more, because the total energy at this point depends on his potential energy, and his potential energy depends on his height and mass, and we just increased his mass, okay? So increasing the mass is going to increase the total energy of the system. And we can just play it through, but we can still see it's turning to kinetic energy, KE max, back to GPE max, back to KE max. Okay, guys, those were the principles that I wanted to demonstrate to you. And that's it.